let's just continue. So we're at the very end of this, and I didn't have time to test again, because in all of this room they're doing something very odd, and the very odd thing is to make an exploit connecting by to your own, to the machine's own IP, to localhost. And I was like, seriously, this is so odd, let's just do my machine. And that didn't work, so I'm thinking that we'll just have to do as they say we should do, which is annoying, but we'll just have to spawn the system and finish this, because I want to get started with the Windows one. That's the next. The same thing, stack-based buffer overflows on Linux, but on Windows, right? x86. So, targets are spawning. I had helped my mom a bit to get service on her car, so I've been messing about with that for over an hour now. So I would have started streaming earlier than usual today if stuff didn't happen, like my mom getting a very apparently scary alarm in her car saying she has to go to service. So though it's not very explicit, the message, so it should probably say you should go to service, not a countdown counting down the days until light was 1 year in service, I guess. But it says like 10 days left to go. No details. It's not that odd that she got worried, really. It's kind of... right, my camera didn't work, so I had to restart my computer. That's probably because I was messing with the Snap camera yesterday and got it working. So, but I didn't want to use the resources to actually run it all the time, so I had everything started, then I had to restart, so now there. So we have TTS working, we have stream to YouTube and Twitch working. Kali has started. Now I can even switch screens. So there. So I have to wake my mom up at it's 7 tomorrow, but she wanted to be woken up at 5:30 to be able to leave home at 8:15. So I think she will manage with 7. I hope so, because I don't think I will be able to get up at 5:30. Let's see. So, right. VPN. The Academy apparently has a separate VPN. I don't know why they have two. I don't think they'll run out of IP addresses, will they? Maybe they will. Sounds very... I guess it's good to have a lot, right? But still, it's a bit of a mess to have to have two. Oh gosh, caps? How did that happen? It's not like it's hard to type 2 letters, so I guess. So let's go here and let's check. We have an IP over here. So if I click this, will it copy it? Yes. So let's Zage, and it's like almost the same address, whatever. It's not the same though. I think we got once we got the same address. Oh, and the password is htb_at academy student I'm copying this. Oh. That's me pressing Control Shift. Oh gosh. What I did was to actually copy again on Kali instead of pasting. There now. So here we have the leave message. We'll have to, I don't think we have to read or anything because I think it's very the same memory addresses and everything. So the purpose is really to read this message text. I think I was kind of like going to test the Try Hack Me Rooms exploit, but let's actually do both. But I feel like these are a bit messy. I mean, if this doesn't work to connect, let's look at the notes so you know what I'm talking about. So I have to open the notes again too. So if we go to the very bottom here, we should have like what we're currently doing, because I added it from yeah, so this is the current full example we're testing here. So we noticed this so I just have to disconnect the phone and connect it again. Okay. Come on. Oh, well, that was a bit funny. By mistake, I clicked the button for pause when I was just removing the phone from the stand. That's annoying. I'll have to be more careful when I do that. Anyway, let's go back to this. So this executable here, leave message, has a vulnerability. We found this buffer overflow. We tested with 2,500 characters probably, since we used that here, and so it was kind of a large buffer. We don't have the code for this one, so we don't know exactly what's inside it. Though we did disassemble it. I feel like that's a bit of cheating, right? But it was a bit too much to read anyway. I mean, not worth it. So anyway, then we did run it with this, and we get this place in memory where it actually tries to return to, right? So then we got the exact position of this, and this is where the return address, or the address we want to redirect execution to, will be put later. But then we found bad characters. That's too much to paste into the notes, so I just skipped that. And then we have, so it's on last stream if you're curious, or maybe someone before even. So recently I haven't had time to stream for a long time. I've kind of felt it's good to do some exercising to get your body in shape. So I've been doing that. Here, this is the one where I changed it. So I put my IP here. Let's see if we have the same IP today. Yeah. Instead of 127.0.0.1, that was the suggested one. So I guess we will do the suggested numbers here instead of this time. And yeah, C format of the output, architecture x86, platform Linux, and the bad cars we found there. We could like put this here, making this a more complete example with actually finding bad cars. So these are just temporary because I was closing my VM down. I really would have wanted to finish this during the weekend at least, but I haven't really had time, not even yesterday. So many things to do. Found 11, she got an eye, and this is not what we'll use now then because of the IP. I think I have the other one still here. So their default one, no, I replaced it. So in my example here I had their one. So if this one works, as the other one didn't, it is definitely something like limited on the box then, right? That you can't access ours. Let's not go ahead of myself. I was going to paste more stuff here, I didn't. Anyway, it connects when it's run. Only we can't do anything, right? At least I tried LSPVD. Didn't get any replies from this at all. Maybe it would have worked to do ID. I didn't try ID. Anyway, we'll have to run it again. Yeah, here it is. So this is of course supposed to be at the very end, since that's what we got there. So we'll have to run HackTheBox again. With the default information, we can check in the room instead of having to actually manually make a line. I'm more like after what they want us to do, right? So determine length, bad character generating shellcode. Here we will have the HackTheBox command that they used with 127, the local host. I was like, why? No, I don't want to do this. Also, they do an out file and then they echo the out file. I'm like, why? So I did a Control Shift again. So Control C. Right, so yeah, they're catting it. They're putting it in a file and then they're catting it and copying it from here. So why not make an out file? I'm just like slightly annoyed. I shouldn't complain about stuff, I know. So it's great that this exists and that it's free, because it's free. So let's actually do a new try here. So this will of course not be in our main buffer overflow notes later, but new try, doing it locally instead of trying to connect to my machine. And alright, it's already there. Actually, we can try the actual one I sent here first. So I was messing about with things. Starting program. But here is the run command. There. So if we were to run this, and it was the usual 443, not this any other port. Let's open a new tab and listen, right? And just giving this a second chance. So let's GDB, let's do the queue so we don't get the licensing information. We still have the glitches in connection there. Leave. I did click tab, nothing. Okay. Yeah, I think the GDB ones we have to type. Maybe /tab would work. So it's done. Now we're going to run it with this command. And there. And let's see if it's connected. It did. So it's not that it's not working, you know. It's just that it's not replying. So I think we'll have to do another SSH. This is what we did in the example, right? So I followed along with our example first. So we'll have to SSH to the same thing again, and I don't remember the IP, so let's just copy this. We could clear this so it's a bit prettier, right? So yeah, right, I still have to go there because I don't remember their password. So password here, there, and just Control-C this time. So now we have one here and one here, and we will use their part too, just to be safe here. Shouldn't think yourself, you just should copy whatever they did, no? I think it's a bit sad actually that so we will listen on 31, 337, just to make sure that we're not like messing their thing up. So let's see, LNP 31, 337. So we're listening on the same box, though it is a sewage, so we will have other permissions, right? That's the reason we're doing this, to get the permissions, not to connect to another machine really. So, but they could have done it another way. Doesn't MSF Venom have payloads that just get a shell? We'll have to test that too, because now I'm curious. Why did they do it like this? And no bad things said about this, right? This one, 0. Now I'm even more curious what we're supposed to read and why this reads 0. Wasn't this what we're supposed to read, and we're not supposed to have read permissions? No? What are we supposed to read then? This is a message we're writing. So we're supposed to read something else. We'll have to look actually, because this is good to know, you know. What are we supposed to read? Okay, road flag. Okay, that's nice. No complaints. Oh, so I'm going to open a third tab just to make the exploit. So now we're doing it. I just didn't copy the out file, so we get the normal text. So we'll never use this again, right? So we don't need to copy this to any special place. Let's just change the format. So first of all, to skip the annoying hoppiness of it, there, and then we just delete there. So now we have this as one big thing. And what I recently copied to this one, here, let's copy it again and update it. So let's do it like this, and let's just take this one. So copy and right. So when I created this, let's just double check. I'm 99% sure that it was the same characters. Yeah, I'm 100% sure it was the same bad characters. So we don't have to like update it. Yeah, so I was doing like example 1, example 2, and then I removed it when I realized it was the same. So 100% sure. So these we copy into here, and we could also probably see, right, so it's encoded. It's 95. Right, so this is not correct. We have 256. Yeah, and these are 95. Yeah. Yeah, it's good. There. So. And then 2060 is to the start of this address. This is all calculated to get this at the right point. So it is after this calculation. So we do minus this number and minus this number to get the correct spot here, which is 2060 from our calculation earlier. Let's just scroll up there. Here, this is where it got the segmentation fault. It tried to hop to this address, and this is the position of it. Right, so that's what we're supposed to go to. So this should instead now connect, instead of this one that we tried just a bit ago, and now we're trying to connect to our, I'm like, do I even hear audio? I had to test. Let's test, send a message, see that it works as it should.
Fix it says.
Yeah, good.
Test.
Good. So I have not had time to check my automatic messages either. Apparently something is off. I don't know what could have happened to StreamerBot. There are updates, I know. I haven't updated though. So let's go back. This one is listening on port 31337. And here we're now going to do the run again, but a new one. And this one will connect to the local machine instead. It's still the same address here. The only change is that in this, all the bytes here, in here we have encoded this, our local host IP instead, and the port. So start it from the beginning, yes. So nothing. So we don't have any connection here. Let's just restart it. Let's check this. First of all, we can just do a simple test by changing these all to let's do 55s or 66s. We did 66s before. It's slow. When I move my cursor, it doesn't move. There. So now we should get a folder ready at this address, and if it doesn't, we'll have to check. Yeah, so this is going to the right address, right? And I think we can probably check memory. Yeah, we should probably like do a breakpoint and check if we want to double check. So this should work, you know, unless this would have changed and not anymore be the correct address. But if it would not have been the correct address, then this would probably have been something else. So on this position, that's where it ends up, probably after here. You know, after it's already done its thing. So I'm a bit curious where this is. Let's go back up in the notes, because I don't want to miss anything here. So I know that this is not a like notes friendly bit of it, but here we have where we found. Here is where the shellcode starts. Here is where we start our knobs, and to get this we did set a breakpoint, right? Yeah, so I'm like removing this almost because it annoys me, but it's maybe not obvious. Yeah, going back. Here's MSF Venom accounts. Yeah, I did save theirs too. So let's just delete this because there's no purpose. I'll keep it in the how the command works bit. So this is the other one. I think I tried it too last time. Let's do a quick test, right? So, no, I want to check the address first. Here, we need to have a breakpoint. I'm a bit sad that I don't remember where I put the breakpoint because I disassembled it to find it. I guess I'll have to do it again. Oh, IF. Hi,
Opinion says.
Welcome in.
Hello.
Welcome in. Yeah, so I'm like stuck at the same place here. Though instead of using connect to my machine, which worked last time, now I tried to itself as the example is, but it didn't even pop anything up there. So since I restarted the machine and everything, I'm thinking maybe something goes wrong here. So this is not what I'm going to do. I'm going to set a breakpoint, but let's just do. We probably don't need to do it all. I think IF. No, totally wrong.
Take a 5 minutes break and come back to it maybe.
Functions. Yeah, I've taken 4 days break from it. So that's not the problem. Yeah, so I think we used puts before.
Fair enough.
So yeah, we'll have to disassemble it. So I have this up, checking the disas. So now let's disas main. Is it just slow, or didn't I type anything? Yeah. sometimes it's slow, so it's hard to know. So if we check the calls here,
I wish I had some idea what you're doing, but this is much more advanced than anything I look at.
yeah, but I can explain if it's something you don't understand. So this is the main function, and this is the assembler instructions when it's disassembled. And we don't need to know right now much more than that we need to make a call, or we need to make a breakpoint at some position in this so we can look at memory while the program is still running. And that's why I'm checking for the last call in the main. Possibly we should do leave message. We can do leave message. We can put a breakpoint when this function starts running and look at memory there, right? Let's do that. So we can continue the disassembling by pressing return. We'll get the rest of it. We could have pressed Q not to get this last bit. You can also look at my notes because I have all of these things, right? I have explanations of all the bits of buffer overflow before here. Anyway, we put a breakpoint. Now we can look at memory, and we can use these commands that I have over here to see. So we can use this, for example. So it's just kind of big chunk of memory we're looking at. Paste. Oh, we got an extra character there. So ESP is a stack pointer. So here we can see where our NOPs start. The NOPs start here, meaning that somewhere here is the address that we want to jump to. We set the address that we want to jump to at the very end here of the command. Here's the address. So we will now see if this is a reasonable address. If CC90, because it's backwards here, it's the endiness of it, meaning that just means it's backwards on PCs. Someone decided that long ago. We just have to live with it. And here is where we see the NOPs stopping. Here is where the code starts. So here our code starts, and the address CC something is not in here, right? That means it won't run our code. We will have to put a new one. So we can decide anything here. The only thing that we need to know about this address that we decide on here in the middle of the NOPs is that it is not supposed to include the numbers that are not allowed. And we checked these a bit earlier, so we know that. Let's scroll up quite a bit. These numbers are not allowed to be in the address or in the payload because this will break the string and it won't work. So here, now we can see 00 is not in any of these, right? Here we have a 00. We couldn't start with this one. And then we have 09, so no 09s here, no problems. 0A, no 0A's, not a problem. 20, no 20. So we could like take anything except for this one.
Are they like reserved keywords / chars or something?
Yeah, exactly. So let's go even further up the notes here. So these characters, they mean something, of course. That's why they're here. And I made a list here. So a string in C is usually terminated, or it's always terminated by a null character. So if you have a null character in the middle of the string, it will just stop reading there, right? So we'll never get any further. Then there's like, for this one, we tested and saw what characters were replaced by a null, actually, because that's what happened. So a 08, I think it was. I don't remember them down here. So let's copy the bad cars. Come on. I'm blind. There. So let's copy these. So all of these characters were replaced by a null. 0, 0. Null byte. Here. So if we paste these here, let's keep it here as an example. So 0, 9, a horizontal tab also broke this and was replaced with a null in the string in that when we looked at the memory. And 0a is line feed, new line. So the new line was also seen as the end here of this. And also 2, 0, which is space. So you couldn't have spaces in there either. So all of these broke it. Otherwise, all characters were just sent in into the string, so we could just see it in memory. It was still there, as it should be. So that's that. Is it clear? Any more questions? Yeah, and this was a suggestion.
Okay, I understand, thank you.
Tester. Great. So that's why we need to make sure that these numbers, as we're sending this into there, as in the string, you know, in the input string, we need to see that this character is not in there. So let's take another address. This one doesn't contain any of them. And then we need to know that D6 and the E8, also the FFs, but the FFs are the same as before. We need to switch them around. So if I go back down here and we'll look at what we sent like backwards now, FF, FF, CC, and now we want this to be D6 instead. So we do D6, and the last one was supposed to be E8 now. So here, right, D6, E8, and now we have E8, D6, FF. So that's just a PC thing, you have to just remember it, called endianness. So that's all. Now we have a new memory address, and this was the new one, right? I'm like, I better check. What did I send last? Nah, I'm not going to check it. We're still listening on this HTTP machine, on the same one we're sending stuff. So I'm just typing anything to hop to the end. Let's do Q. We have seen where in memory this is. It looks okay. So now we go back to the command here. And now we're going to change these 6s here. Right? So we can do this manually. It's so tiny bit. Things to change. I could have arrowed up one more time though. We have the FFs there. So D6 and I removed the X too. So \X just means this is a hex value, these digits. And E8, every hex digit is 4 bits. That's why you have 4 plus 4. So 2 hex digit is 8 bits. So that's why we have 2 of them for every character. So every character have 8 bits, right? So too many numbers in my head now, right? So there we go. And we want to restart the program. And we do have a breakpoint here, but it died before this. So what happened? This is interesting. I'm actually just going to quit this. I want to quit this. Yeah, so we'll do it all again. And I'm curious to see if it has a new memory address. That's one of the reasons I'm restarting it. So we're running it again. Now we can't arrow up, we'll have to type. So if it, I'm like, I did a break, right? No, I didn't. Yeah, I forgot to. But it works anyway. Because we still had it in memory. So sometimes it doesn't want to, after the program exits, doesn't want to do it. Yeah, but that's when it doesn't break. When it's segmentation false, it still has it available for us. Right. So before I had it actually quitting in a good way, actually not getting buffer overflow because of these break characters, ending the string, making it shorter than it was supposed to be. And then I had to make the breakpoint because of the bad characters ending the string, terminating it too early. So so now we can just run it and we can test stuff. And I'm going to use this last one because I think it's correct, but I'm not sure, so we'll see. I don't want to copy paste more than I have to. So to run, it's just slow. I didn't do anything now. I just clicked it once and then it popped up. Not pasting. So confirming here, we have first character 55 a lot of times. So the number of characters we want to hop into before we type the address. Then we have 256 because we have 256. NOPs. NOP is no operation and it's hex 90. And then we have the actual instruction that we want run. And then we have hopefully the address to these in the middle of the NOPs. So it will just do no instructions until it ends up in the instructions we want run. So that's that. If it works, we did copy the right code, otherwise I'll have to try again. So, looky. So this is a new message. This is what we were going for. So apparently I run the same thing after already having something run. And it didn't work, but when I started it again, it worked. So I have to look at memory later. And this process didn't stop. It's still running, meaning we have this. So if we do ID here, we should be root. No, we're not. So it is still something off here. This is interesting because it's supposed to be suited and the program is supposed to run this. Bin dash. This feels so odd. Yeah, so I know that this should work, really. So if we do ls here, we now have a connection at least, right? So if we were to cat the root thing, we can't do it, right? Because we're not a root. So I think it was flag.txt. And it will say permission denied because we don't have access, because we're not root. So this is all logical. The problem is that we're supposed to get root. Come on, let's try again. So let's look at memory now. It exited with code 1. I'm kind of assuming that the memory check command that we used before this here, that this won't work now. But we will test it to see if it works. If it works, this is not logical because it's exited. Yeah, so now it says no registers. So ESP doesn't exist, it's not running. So if I happen to know the address, which we might happen to know, we might just be able to do it anyway. Let's say that we do this instead, right? We have the address that this comes down to. So let's see if it if it's the same. So I'm interested in why it ran that. So let's do X. We want to see hex. We want to see 2000 hex. We want to see it in hex byte format, 1 byte separate. And the address we want to see is, yeah, it managed. It's so slow, so I think, what, did it fail? And it cannot access this memory, which is kind of logical. So we'll have to restart it with the breakpoint this time, because it exited as it's supposed to. So I have to remember how to make a breakpoint. And break function name. Yeah, I almost remember that much, but what on earth was the function name? I just checked it before here. So right, on basic information, to get info functions, we list all the functions and their addresses. So the function like names are just pointers to these addresses. So when we want to disassemble when we disassemble main, then we really disassemble whatever is on this address. But it seems to be able to do it like, it's a bit tricky, because I managed to make it disassemble. That was R2 though, and this machine doesn't have R2, I think. But I managed to get it to disassemble things that were not actually code, just bytes. So, am I blind? Where is it? The function? I think it's like the same name as... something that's not at PLT and is not start. Here, it's just before main. I'm so blind. So leave message. Very, very hard to remember. I think the program name is leave underscore message though, so it's a bit tricky, right? Leave message not defined. So this is funny to me. Why? Let's see. Say yes, and let's try again. And let's just double check. It didn't have. I still want to do R2 now. I feel it's much better. So I could find mine, right? Let's look at main. And it doesn't have any other name. Because in R2 it would have another name. It would have like dot. So, and it should already be loaded, right? And this is a run command. And this is the last memory address. We could just do, I'm just arrowing up. We don't have more in this memory. This is good enough. So, yeah, look. So I would like to look at memory before. This is so nice to see a lot of random stuff happening. Yeah, so how do I find the memory address before actually running it? I have to like break it main.
Panda Tongue says,
Let's break main.
where's your harness at when you're climbing through code?
Hi Panda, hope you're great. So let's break main instead. Let's actually, I'm going to quit, and then we run it again. So we have a fresh slate to start at, and instead of like doing anything else, we will just, I think, break main. It can be done like that. Breakpoint, and then when we run it with our, we count our up because it's gone thingy. Let's copy, just copying from the other screen here. So we have this up still. Yeah, you saw me testing that yesterday. I should have like tested a bit before. So really, these addresses, this is not the correct address at this point, right? We don't know the address anymore or yet. So we will have to get a new one. There. So we're at our breakpoint. Now we can look at memory and have a bit more control there. Actually, I'm going to copy the memory command to the other screen so I can just easily paste it whenever I need it. There. So here, paste, and we can see our end of the quite a few 55s, the start of the knobs here that are supposed to be 256, and if we click again, we get the code starting actually here. So to do this the same run again, we would use one of these addresses without that doesn't contain the bad cars, and we should be listening here again then. So we did get it working once, but we were not root. So it's a bit odd actually. It feels like it's just jumping around in memory without my control. That's not a good feeling. So here's what the actual exploit is, and it's MSF Venom, and we have copied their command to create it. Then we have, let's see, how many? Yeah, I was looking for the 66 or 66. It's hex 66, so it's not 66. 66 implies it's decimal numbers, which is not. So after this bit of memory, we don't know what it is, whatever, you know, it's outside what we've been playing with. So we put all the way down here. This is what we put in memory. So now when we run this again, so we had D6 E8 should have been an up. So D6 E8 should have been here in the knobs. We didn't run it though, right? So if we quit this one, and now we let's clear the brakes, right? I have to check how do I do that? So maybe I don't know how to do that in here. So we don't have to, we can just continue when we get there. C to continue, just continuous normal execution from the breakpoint. So if we go back up and we replace this with our memory address, so FFFF, and then we have one of these. Let's do D6 B4 this time then. Very similar. So it's slow. D6 B4, right? D6 B4, confirming. D6 B4 is in the middle of the knobs. We have them both after and before, and we run this, and we want to start it from the beginning. Now we're at the breakpoint, so let's actually look at memory now again and confirm that D6 B4 is still in the knobs. So D6 B4 here is still in the knobs, right? So we don't have to see more. Now we press C for continue. You should continue execution, and error resetting breakpoint. Function main is not defined. Okay. We got our connection. Let's do ID. And we're still the HTTP student. So this is like nothing inside my control. Because I think that the program itself is supposed to use the SUID, the permission changing, and when we disassembled it before, I think we saw that using it, right? The functions. Let's scroll up to the functions. I don't know if I showed all of them. Sorry for the long scroll. Oh, we're actually here. No, that's the disassembling. So let's see here. I think I saw something. We should go to the disassembled instead. This is not useful. Set result ID, printf, closer, copy, puts, exit. Let's look at the code. So, yeah, set, I think this is what's supposed to do it. So let's actually copy this and Google it, because I'm curious now. So, set real, effective, or saved user or group ID. And this is done here in the code before the call to the leave message. So we don't have to understand all of the details of everything here to see that this looks like it should work, right? We could step through it, look at all of the code. I don't want to look at the code for this. Yeah. So I'm like curious if something is wrong with this. Also, what does it want? It wants the contents of the flag file. Yeah. So it might be broken. It might be broken. It's not like it's the first time that happened, right? So, an unprivileged process may change its real UID, effective UID, and saved set user ID, each to one of the current real UID, the current effective UID, or the current saved set user ID. Privileged process. Cap set UID. capability. And this is a real SU, it is not the SetU capability. Regardless of the changes. So I think this is what's supposed to give us the permissions that we don't have. So since the connection works, you know, it's not like I can rewrite the program because we don't have high permissions on this. So let's quickly see. So HackTheBox. See if anyone else had problems. And it's buffer, overflow, and let's actually copy the ID string, because if someone else had problems, they probably wrote this, right? I got this instead of root. So this is from the forums. Is this the same one? I'm getting a shell. HB student, please help. Finally rooted. So they continued. They got this first, and then they got this. So they managed it. I also got stuck on this. I followed all of the stuff that I was taught in the tutorial. I have been reading and watching. Did you get a reverse shell? How was this reverse shell? What user logged in as? You know how sticky bits work, right? Find the file with the sticky bit set. Okay, okay. Okay. Is this for exactly the same? Yeah, thanks,
Kitty
Nori.
says.
That's great.
Odgaverja 14 Noiki Wanyu.
Translated from Indonesian.
Okay, so you're speaking Indonesian and that's English? I guess I'll just have to think more. The thing is that we had like a very similar thing, but not the same, right? So they expect us to think. I didn't think they expected us to think. Find the file with a sticky bit set. Remember when you're inside GDB and run the same as executing the script with the parameter as follows. So let's see what the next one says. You can only debug a setu and seted program if the debugger is running as root. The kernel won't let you call ptrace on a program running with extra privileges. If it did, you would be able to make a program execute anything, which would officially mean you would. Okay. Alright, so we're not actually supposed to run it in there. Yeah, I think since... Didn't it change its memory address today? Just now? every time I restart GDB. So how would I then do it? This is just a general question. So 124 is just a random number. But it's a bit messy. We could just have all of these be knobs. We don't really have to have any 55s. I think you know. Yeah, you're already in the machine. So I think I remember that there were no other files there, but maybe I should look at the directory. Right. Yeah, so since I had this problem last time and I didn't remember the thing at all, really well, I remember bits. I did, before leaving work, while I was working, I checked the end of a YouTube video on this. And they did exactly what I did. And the only difference from what they did, what I did, that they did it on the machine, and I did it to my machine. Right? And we do have a connection now on the machine. And they were root. So that's how this started, at least. Maybe it's not that like that anymore. But let's see if there's anything interesting here. Multiple ways, including this. Leave a message. What? Why would they do that? So the person who didn't find it found it finally. Someone probably said congrats or something. Oh, give me a hint. Of course. Yes, I guess we should just see it as a normal box. Yeah. Think outside the shell, not outside the box or anything, outside the shell. Okay. So my problem with this is that it changes memory addresses. So when I close it down, it changed the addresses. So we're still connected to the machine. I guess. So I didn't really look at that video very closely. I just know that they used Netcat to catch it. so they used the thing, right? They didn't do something completely different. So if we lay here, just to make sure I didn't forget, we just have these files, right? And leave messages owned by root. So this is what we're running to get this shell, and just UID. And I thought from reading maybe I shouldn't have disassembled it. Maybe that's just confusing. So let's just listen again and just run it outside of GDB with the same command and see what happens, right? So let's just copy this here. So, and actually, yeah, I guess I'm quitting this again, and then we're laying because what was the name? So leave message, paste. We're running this outside of GDB with the same memory address. So I don't think it even ran it, did it? Okay. So this surprises me because it changed the memory address, right? And now it worked. So now we have root there. So meaning we can read the file. So I have to go up and look. So okay, so SUID, what they said really in the text, what I read in this, they said you can never use a SUID within GDB. That's what they said, because then you would have problems, right? But let's see here, memory address. Let's look here. So here we're at, yeah, so we're at D6 already. So it's when we reset the box, that's when we get a new memory address. So as long as we're in the same session, D6 and D6. So as long as we're in the same session on this specific HB machine, we have the same address. Even if we run it, even if we restart GDB, if we run it in GDB and outside, because I have different experiences when running this. So, but the GDB thing is a big thing to note down. And I'll have to reread this, what they wrote, and I have so much training ache. It's crazy. Oh, I hardly can work today. Oh, and also I usually can bend my arms more like this. It's so the indoors climbing was really good training for me.
Moved big stretch.
Yeah, no, I can't stretch a thing today. So let's just cat this thing so we have that done first. Flag.txt. So I'm going to copy this. But I want to know more. I want to check this out. We want to make sure that we have this in our notes. So let's go to the let's close this one. So let's paste here. Yeah. So why should these stay forever? So before we continue, I guess we could click finish. Because it doesn't have anything to do with the room. We want to do the Windows one next, but first I need to know details. GDB. GDB set UID. No, just UID. UID program. So so annoying. Just because it's Unix stack exchange code, we have to do that again. When I did shell and execute it out in shell, GDB. However, when I do a GDB, it starts the process as a normal user. Yeah, and launches a user shell. This is the whole thing that we're exploring now. So, you can only debug a set UID or set JID program if a debugger is running as root. The kernel won't let you call ptrace. This is exactly the same text on a program running with extra privileges. If it did, you would be able to make the program execute anything, which would effectively mean you could run a root shell by calling a debugger on bin su. Right, because su has suid set, so there's other stuff required to actually use the suid. If you run GDB as root, you'll be able to run your program, but you will only be observing its behavior when run by root. If you need to debug a program when it's not started by root, start the program outside GDB. Make it pause in some fashion before getting to the troubleshooting and attach the process inside GDB. So we need to test stuff. I have to take a short break. So we solved the problem. We know the reason, but we don't know why it didn't work. Well, I guess it's just this box, Nix buff 32 skills, that can't connect to another machine using this. It might work now though. We could try again. And let's
Opinion says.
Hi Nori. No sound, fix it.
So this mic must have disconnected then. So that's odd.
Fix it.
Fix it says.
Test.
Opinion says.
Name checks out.
Yeah, but I hope to fix more things than that. Yeah, so I'm thinking, since there needs to be a way to pause a process to be able to attach to it and put it connected to GDB, and this program is simple and it just takes input and then it crashes if it doesn't get input, so there's no way to pause it, and the input is the only thing that's happening. Command line input. So I don't think there's any way to pause it. So I think we'll have to survive not testing it and just adding this to our knowledge base that this is how it works. And let's go to the notes here, and I have added it here. Attach process ID, and here let's fix this. So this is important. But I want BRs here. So let's actually do all the lines, I guess. So you can only debug a setUI or setted program if the debugger is running as root. Otherwise, you could just call GDB. I think 4 is the best alternative, and have root on. Yeah, on. Let's do on. Come on. So apparently I couldn't edit it in that mode. So the font tag makes it not as editable. If you run GDB as root, you will be able to run your program, but you'll only be observing its behavior when run by root. If you need to debug the program when it's not started by root, start the program. Yeah, and I didn't get the source for this really. We want to have our sources because I don't want to steal people's stuff, you know? That's mostly why. It's not like I don't care about sources like that. Good information is good information. I recently closed tabs. I think it's this one. No. History. Is this the one? Yeah, Unix. So let's just do from. So there. I edited a tiny bit here to get rid of some text, but I think it's all interesting anyway. Or we could just skip 2 lines at least. It's still too much stuff here. So it's simply so we don't have to read this if we're not checking this, right? Actually, it's supposed to be SG. ID. Set user ID, set group ID. So, yeah, I think I'm good with this one. It's okay. It's okie dokie. So, oh, right. I have to click finish again because I overwrote the history where we ended up in this room. So what happens with continue here? But I've done this. I don't get it. So what's dashboard? Uh-huh. But this one has a continue too. So why does this one have a continue? Is it because of this one is not checked? To me it looks completed. Oh. So I did not click that button. So now it has a view instead of continue as this one. So now we want to do stack-based buffer overflows on Windows. And then we have to unlock this. I don't know why this one is here, and I don't know how to remove it. If I click it, can I remove it then? Oh, it's a part of this thing here. So I did not want to enroll into this, really. So what if, can I go back to the dashboard there? No, this is not what I wanted either. But it says that this is completed now. So let's just search for buffer overflow windows. I don't have 160 of these. These are the free ones. Stack-based buffer flow on Windows. So, if I put Windows in here, it didn't find it. I did click. So we're in the Windows one now. Yeah, and this is why I had clicked this to test, see what happens. I thought it would say you don't have this money, but it didn't. It just popped it in there. So if I unlock this now, and it asks me, do you want to unlock for 10? We have unlocked it for 10. And then I think we will get those 10 back when we finish it. So it's free. So I guess I will read this. Windows binary exploitation has advanced through the years, from basic Stack Overflow techniques to advanced security bypass techniques and heap exploitation, to reach a level of understanding that enables us to successfully exploit even the most advanced application. We must have a firm grasp of the fundamentals of Windows binary exploitation, which is the main aim of this module. It's the first step on Windows binary exploitation. It will take you through the following. What is binary exploitation and buffer overflows? How to debug Windows programs. Basics of local and remote fuzzing of Windows programs. Finding and using return instruction to subvert the program execution flow. Okay, message.
Multinational conscription says.
Cheap viewers on. Web link.
Yeah, I
Fixerbot
wish I
says.
could make the
Message
TTS
removed.
not read it. Oh. I'll talk to Security Live and see. Crafting malicious payloads and scripts to gain local and remote control through buffer overflow vulnerabilities. Developing a functional multi-tier Python exploit for stack-based buffer overflows, which can be used as a basis for other buffer overflow exercises. Throughout the module, we'll be attacking two different programs. First, we generate a malicious WAV file that exploits a buffer overflow vulnerability in an audio converter to perform local privilege escalation. Then we'll move toward remote escalation by attacking a remote server to gain remote code execution over it, after debugging the vulnerable binary locally and developing an exploit. In addition to teaching the above topics, this module will also cover a short history of stack-based buffer overflows, a real-world example of this vulnerabilities, the process behind developing a stack-based buffer overflow, fuzzing the program's fields and parameters, identifying the exact offset of our input's location within the buffer, controlling the address of the return instruction. It's like the same stuff, of course. Identifying and eliminating potentially bad characters, learning multiple methods of finding and utilizing return instruction to subvert execution flow, generating shellcodes and executing them through the return instructions, listening port gradually to identify the length of our buffer precisely, adapting our local exploit to attack remote ports. I don't know what this means. Crest CPS ACRT related. Whatever. This might is broken down into sections. Yeah, so let's just continue. So they suggest us doing intro to assembly first, and I'm not going to, but I might later. If it's very intro, maybe it's not interesting. But if it is not, how would you know? Is it free? That's the only thing I care about. I don't want to pay stuff if it's... You kind of need to know stuff about what they are, right? So let's actually duplicate the tab. I don't want to type if I don't have to. So if we paste this, it found it. So is this a free one? Here, how do I see this? Is the only way to click the actual button? It looks kind of basic, but like libc functions. Coding techniques? Yeah, why not? There's a YouTube here too. So what happens if I click here? Will it like automatically do anything? So this is 40. Yeah. No, it's 100 even. We have 40 too little. So that's a no. So I don't understand this way. You know, if it was like a subscription and you could just access anything, then I would pay for it. I would probably get them more money than I don't want to give them from buying stuff like that. I don't know if it's good, you know. If I click something, find it's bad, and I have paid specifically for that, then it's like money thrown away. If it's a subscription and parts of it is good and parts bad and I can just click and see whatever, you know, then it's more free and I can decide what I want to do myself. So